In this video, we're going to do some interest problems. First, we're going to look at the compound interest formulas. The formula is here. After T years, the balance A in an account with principal P and annual interest rate R is given by this formula. For n compounding periods per year, we have a formula, and for continuous compounding, we have a different formula that uses E. Remember that E is not a variable, it's a constant, and you can use the E button on your calculator. So first we're going to find the value of an investment of $10,000 for 5 years at an interest rate of 5.5% if the money is compounded semi-annually. So we're going to plug into our formula here. We're going to plug in $10,000 for P, that's the principal amount. We're going to plug in 5 for T, because that's the time in years, and we're going to plug in for the interest rate. So when we're plugging in for the interest rate, we plug it in decimal form. So that means that we would plug in 0.055, because we would divide by 100 or move the decimal point 2 places. So what this is going to look like is I'm plugging in 10,000, and then I have parentheses 1 plus 0.055 divided by 2. Compounded semi-annually means that it happens twice a year. And then it's going to be raised to the power of 2 times 5. So the n gets plugged in 2 different places in my formula here. Now I'm going to type it into my Desmos Scientific Calculator. And I like to use the Desmos Scientific Calculator here because I can type the whole thing in all at once. And it looks really nice, and I can just get what the answer is, instead of having to do it step by step, like you might have to with a different kind of calculator. So here is what I'm getting. If I want to multiply 2 numbers in the power, I want to put that in a set of parentheses like so. So here's my answer, $13,116.51. Put that in here. Now we want to do the same calculation, but compounded quarterly instead of semi-annually. Quarterly means that something happens 4 times a year, so my n is going to be 4. All of the other values are not going to change. And the nice thing about the Desmos Scientific Calculator is that I can just change these numbers, and I don't have to type everything in all over again. So I can see that when I change that to 4, I get $13,140, and this would round up to 67 cents. And now if we want to find the value when we're compounding monthly, if something happens monthly, it happens 12 times in a year. So my n is going to change to 12. And I can see my answer here, $13,157.04. So what you should notice here is that changing the frequency of compounding does change the value, the amount of money that I would get. If I compound more frequently, then I'm going to get more money. But it's not a very significant change. I'm not making significantly more money. It's just, slightly more. This is going to be $17 more between quarterly and monthly. So you should get answers that are very similar to each other. But the more frequently you compound, the more money that you're going to get. The last one here is compounded continuously, and that's the one that has a different formula. So my formula is that A equals P times E to the RT power. So 10,000 is still going to be my principal. E, we're going to use the E button on the calculator. And my rate is still 5.5%, and my time is 5 years. So plugging this in is going to look like this. I'm going to do 10,000 times E raised to the power of 0.055 times 5. So I am still converting that interest rate into a decimal. And Now I'm going to plug this into the calculator. I'm not going to change my numbers here. I'm going to start over. So we have 10,000. And then to get the E button, remember we click on the FUNC. We can use either E button here. I'm going to use the one that will put my cursor into the exponent because I know that's what I'm going to want to do next. Click back on main to get back to the screen with the numbers. And our power here is 0.055 times 5. Again, I'm putting that in parentheses where I'm multiplying in the power. And so again, I get a value that's higher than the other values, but it's right in line with where they are, and that is what I would expect. So $13,165.31. For the final problem here, we have a formula that models inflation, where C is the value today, R is the annual inflation rate, and S is the inflated value T years from now. The inflation rate is 6%. How much will a house now worth $465,000 be worth in 10 years? So again, we're going to plug in here. C is the value today, so that is my $465,000. And then 1 plus, my inflation rate is 6%. And just like before, we're going to move the decimal point 2 places or divide by 100 to write that as a decimal. And then my exponent is going to be 10 because the time is 10 years. So bring back my decimals calculator. I'll type that in. And our answer here, $832,744.18.